What if I told you that everything you see around you, every star in the sky, every atom in your body, and even time itself all began from something smaller than a pinhead? Today, we're diving into the most mind-bending story ever told: how the entire universe exploded into existence from absolutely nothing. For centuries, brilliant minds believed our cosmos stretched infinitely in all directions, eternal and unchanging. Then Einstein shattered this vision with his theory of relativity, showing us that space and time could bend and warp. Shortly after, astronomer Edwin Hubble made a shocking discovery that would rewrite everything we thought we knew about reality itself. Hubble noticed something extraordinary when he peered through his telescope. Galaxies weren't just sitting there motionless in space. They were racing away from us and from each other at incredible speeds. The farther away a galaxy was, the faster it was moving. This could only mean one thing: the universe was expanding like a balloon being inflated. But here's where it gets wild. If everything is moving apart now, then logically, everything must have been closer together in the past. Wind the clock back far enough, and you reach a moment when all matter, all energy, all space itself was compressed into an unimaginably tiny point. This was the birth of the Big Bang theory. The smoking gun came in 1964 when two scientists accidentally discovered something incredible: cosmic background radiation. This faint energy signature fills every corner of space, like the afterglow of an ancient explosion. It was the universe's baby photo, proving that everything really did begin in a hot, dense state nearly 14 billion years ago. Now let's talk about what actually happened during those first incredible moments. Forget everything you think you know about explosions. The Big Bang wasn't a bomb going off in empty space. There was no empty space for it to explode into. Instead, space itself was expanding everywhere at once, stretching from something smaller than an atom to the size of a football in a fraction of a second. In this scorching hot environment, temperatures reached trillions of degrees. Energy and matter weren't separate things like they are today. They were essentially the same stuff, constantly transforming back and forth. Particles called quarks popped into existence for tiny fractions of seconds before annihilating with their antimatter twins, releasing pure energy that created more particles in an endless dance of creation and destruction. Something fascinating happened during this chaos. For reasons we still don't fully understand, matter gained a slight edge over antimatter. For every billion antimatter particles, there were 1,000,000,001 matter particles. When the cosmic dust settled, that tiny imbalance meant we ended up with a universe made almost entirely of matter, with virtually no antimatter left. As the universe continued expanding, it cooled down rapidly. The frantic particle creation stopped, and quarks began sticking together permanently, forming the first protons and neutrons. By the time just 1 second had passed since the beginning, the universe had grown to 100 billion kilometers across and cooled enough for the first hydrogen atoms to form. Picture this early universe as an incredibly hot soup, 10 billion degrees Celsius, filled with hydrogen gas and radiation. Over the next few minutes, things settled down dramatically. The universe entered what scientists call the Dark Age, not because anything sinister happened, but because there were no stars yet to produce light, and the thick hydrogen gas blocked visible light from traveling. This darkness lasted for millions of years until gravity began pulling the hydrogen gas together into dense clumps. When these clumps became massive enough, nuclear fusion ignited, and the first stars burst into brilliant light. Their intense radiation cleared away the hydrogen fog that had been blocking light, and for the first time in cosmic history, the universe became transparent. But here's the ultimate mystery that keeps scientists awake at night. Everything I've described happened after the Big Bang. But what about the Big Bang itself? What triggered this cosmic birth? At that moment, our understanding completely breaks down. The laws of physics stop making sense, and even time becomes meaningless. To solve this puzzle, we need a theory that unifies Einstein's relativity with quantum mechanics, something the brightest minds in physics are desperately trying to figure out. Until then, we are left with profound questions that may never have answers. Was our universe the first, or have there been others before? Did the Big Bang have a cause, or did it simply happen according to laws we haven't discovered yet? What we do know is remarkable enough. This cosmic story gave birth to galaxies, stars, planets, and ultimately, us. Since we're made from elements forged in the hearts of dying stars, we're not separate from the universe. We are the universe becoming aware of itself, asking questions about its own origin and destiny. So the next time you look up at the night sky, remember that you're witnessing the aftermath of the most spectacular event in history. And you're not just observing it, you're part of it. But as mind-blowing as the Big Bang is, every beginning has an end. If you're ready to explore how this vast cosmic masterpiece might ultimately unravel, jump into our previous video, from the horrifying Big Rip to the silent heat death, and even a possible Big Crunch rebirth. You'll see how dark energy and entropy could spell the ultimate apocalypse. Tap the screen now or check the link in the description to witness the final fate of everything we know. And don't miss a single chilling scenario.